So gently clamp the RGB LED into a lens holder. And place it at the end of the rail. To use one of the LEDs, choose the colour of the LED. In this instance, let's choose the red one. Place it into the negative terminal, and then place the yellow onto the positive terminal. Make sure that we are reading a low number here, less than 5 volts, so that we don't damage the LED. We turn it on, and we should have a nice bright LED light. The brightness can be adjusted by adjusting the voltage. Place the clamp into an X carrier and put the end of the optical fibre really carefully into the clamp. Make sure you don't touch the end of the fibre. Place the fibre pointing towards the LED, which is turned off, about 10 centimetres away. The other end of the fibre needs to carefully be inserted into the spectrometer. Again, don't touch the end of the fibre. With the spectrometer plugged in with the USB cable into the computer, now start the Avasoft software. With the LED turned on, press Start. To adjust the size of that peak, we can change the integration time. We can increase it to, for example, 100 milliseconds. We can also increase the number of spectra that we average to, for example, 10. To correct for the background light, make sure the LED is switched off, and we'll collect a dark spectrum. You'll be doing this with the room lights turned off to make it even better. Click on Dark up here. We'll do that every single time we change the collection parameters. Now, when we turn on our LED and click Start, the spectrum we collect should not have any contribution from any of the interfering room lights. We want to collect a spectrum which has roughly 50,000 counts at its peak. So we can do two things. One is increase the integration time. Two is we can change the position of this fibre and see if we can improve the alignment. Make sure you fasten it tightly in place. Any movement is going to change the amount of light that you collect. To export this spectrum, we'll go to File, Export, and we'll choose ASCII or Excel, which will save it as comma separated variables. Both of these can be opened in Excel or even any other package for that matter. You can then go through all of the different LEDs, collecting their spectra. And you can even try things such as the desk lamp and try pointing it towards the fluorescent tubes on the roof. You might even like to use the torch on your mobile phone and see what the spectrum from that looks like. Now we're going to be looking at the laser, which is a much more intense source of light. So we need to protect the optical fiber and the spectrometer by inserting a ground glass diffuser between the light source and the optical fiber. The laser will go in place of the LED. We'll plug in the black cable into the power source. However, we're going to use a multimeter in series to measure the current that is going through our laser diode. So use another cable to connect to the positive terminal, and we'll run this red one into the common. Now when we switch on the laser and increase the voltage, we may possibly see something. There we go. Boom. The spectrum for your laser should look very narrow, like this. Remember that every time we change the voltage and the drive current going through the laser, the spectrum is going to change quite dramatically. If you want to change the integration time or the averaging, you will always need to collect a new dark spectrum every time. If your signal is still too strong or still too weak, remember you can always adjust the alignment of the optical fiber. If it's too strong, then deliberately misalign it. But if it's too weak, then you can move the fiber in closer. Again, you'll need to collect a new dark spectrum every time you do that. Finally, we're going to measure the optical output of the laser diode. To do this, we'll use one of these power meters, which can take a very high intensity of light. We don't need the diffusing screen any longer. Carefully align it so that the laser is incident onto the center of the detector. To take a reading, push and hold the button. By controlling the voltage here, we can control the current going through the LED. At the same time, you will be monitoring the optical power that it's putting out.